Emma is playing a popular video game and is determined to beat the high score. You guys like video games? Yeah, I like Call of Duty. Only to kill zombies, though. If I can kill zombies, I'm pretty happy. But Emma's trying to get that high score down, right? And every time she leaves the game, apparently it saves her place. So it's saving her high score as well. And then she picks up the game maybe the next day. Emma downloads the video game on Monday night and starts playing, scoring a bunch of points. On Tuesday, she scores an additional 500 points. On Wednesday, she doubles her score from the previous day. On Thursday, she scores the same number of points that she scored on Monday. Miguel's teacher asks him to write an expression that represents Emma's total score after she is done playing on Thursday. Miguel writes the following expression. And that's what we got, that 2 times the quantity, p plus 500, then plus p. Miguel's teacher lets him know that his expression is correct. Write in words what each piece of Miguel's expression represents in the story problem. Okay, well, here's what we got. We got this 2, and then we got this p plus 500 stuff. And then we got the p. So the 2, let's start first with p plus 500. Now remember that one of the key things in this problem is that it's saving her score every day. So what would p plus 500 represent?
500p.
What? Yeah?
500p.
It's close. It's close. Yeah? Bam. That's close. Uh-oh.
Is Emma a he?
No, did I say he?
Yeah.
No.
Look, Miguel's teacher asks him to write an expression.
Yeah, that's because Miguel is a him.
Oh.
But they're talking about Emma, a she. So, p plus 500, where does it talk about 500 in this word problem? Yeah, very good. It's this additional point stuff right here. So, this would be Monday's score. Monday, and then plus 500, right? Which really, I mean, if we really wanted to simplify that, that would be Tuesday's score. Tuesday's score at the end of the day. Does that make sense? That's what it says. On Tuesday, she scores an additional 500 points. So what does that mean P represents?
What she scored before?
Yeah, and what would that be before? Well, what day was it? Monday, right? So this would be Monday's score. And then there's 2 at the beginning of this expression. Why is that 2 there? Why is it times? Yeah?
It says on Wednesday.
Excellent. 2 is the doubling of the score. Of course, that's double Tuesday's score, which is essentially what it said. That was on Wednesday. She doubled her score from the previous day, and the previous day would be Tuesday. So, we've identified all of that. Well, Nevea, whatever, writes the following expression to represent Emma's score on Thursday. This person wrote 2p plus 1,000 plus p. Well, the teacher lets her know that she is also correct. How did that person represent the problem differently than Miguel? So what do you guys think? Yeah?
He was already distributed from the first time.
Very good. Very good. And well, I guess we'll get to that. That's very good. So she's doubling the P, which would be Monday, and then the 500 extra from Tuesday. Doubling both would give us that value. So that is what she's done. You could just write distribution if you want. That's fine. Distribute the 2. Can you think of another expression to represent Emma's score on Thursday? Is there another way we can represent this? Yeah, what would you guys do?
Combine like terms.
And what would that give you?
3P plus 100.
3p plus 1,000. Very good. All right, another one you guys may like is 1,003p, right?
I know the answer.
Yeah.
It's 333.3333333.
All right. So that's a good point there, Josh. Is we can't combine this with that way with the 100. So what you're thinking of is solving an equation. We're not there yet. Yes.
What do you combine the 1,000? Yeah, the 1,000.
Well, 3p plus 1,000 is 1,003p, right?
Yeah.
Not 100.
It's just like
That's very good. We can't combine those, right? Why can't we combine them? Go ahead.
because they're not like terms.
Very good. They are unlike terms. Unfortunately, I will usually see this on the first unit test, though. So don't do it. We can't combine unlike terms. And then finally, Radhyan. Emma scored 700 points on Monday. So if that was the case, how many points did she score at the end of the day on Thursday? Well, in the expression up here, let's just use this one because we can see it. What represents Monday's score? P, right? So P equals Monday's score.
Times 3.
So yeah, we're going to have to take Monday's score, which in this case is 700, right here. And we're going to replace P with 700, because that's what it is. So which expression do you guys want to use? Last one we found, Nevia's.
Scheme of it.
I can't,
Why?
because it's not an equation. Well, let's use that last one because it's convenient. So 3p, so the p we're going to replace with 700. Then we're going to add 1,000. So 3 times, of course this is order of operation stuff. 3 times 700 is 2,100.
2,000.
And then we got plus 1,000. And sure enough, we found that Emma scored 3,100 points by the end of Thursday. Now this should work also for any of the expressions that we found. So if we did 2 times the 700 plus 1,000 plus the other p, which is 700, you would find that that answer also is 3,100 points. Same with the one on the previous slide as well. In this lesson, we will study linear expressions. A linear expression is, well, if we graphed it, let's say that was our graph, it would give us a straight line, assuming that was straight. If we were to graph it, of course, it would have to be equal to some other variable, like y usually. But all of these examples that you see here at the bottom are linear expressions. Again, meaning if we were to graph them, it would give us a straight line. So, if that's the case, then let's say that we had these expressions. What would make them nonlinear? Well, something like an exponent would. As long as that exponent is not 1, then it is no longer linear. No, unless it's 0, but we'll get into that. Notice this 25 doesn't have an exponent or a variable. So if we squared it, it would just give us a new constant, which means that all constants would also give us a straight line. Here are these 3 equivalent expressions that we've already found from that word problem in the video game. And we identified that P was the unknown, which represented Monday's score. And simplified. This would be considered completely simplified because we've combined all the like terms. And so it takes on this form ax plus b. That's not completely important, but some teachers emphasize that more than others. By the way, since these are all equivalent, You could have found maybe this one or this one. It just depends on how you think about the word problem, all right? For ease of communicating mathematical ideas, we'll consider the linear expression in this form, ax plus b, where a and b are numbers and x represents an unknown. Simplified form of linear expression. In the example above, the simplified form of the expression is 3p plus 1,000. So let's look at number 2 then. We got 5x plus negative 3x minus 6 plus 4. Justify with words or pictures, then evaluate the simplified expression when x is 8. Okay, so here's what I'm going to do. Last year, maybe some of you guys used tiles. Maybe you didn't. I'm going to use tiles. Okay, so notice in this first term we got 5x. So I'm going to give myself 5 x's, and these are positive. All of these are x's. And then the next term is negative 3x. So I'm going to write those out. They're the same box, but I'm going to use a different color to indicate that they are negative. So there's a negative x and a negative x. Oh, I only have 3, right? So I need to erase these 2. And then we got a negative 6. So I'll indicate these with circles 1, 2, 3, 4, 5, 6. And all of these would represent a positive 1. All those are negatives. I apologize. These, that's a minus 6. So these are all negatives. And then we got plus 4. So, I'll do this. These ones will be positive ones. Now I am using a different shape on purpose, and that way we know what to combine and what not to combine. We can't combine rectangles with circles, and this helps us to kind of see that. So let's go ahead and start eliminating stuff. Here we've got this x, which will cancel out this negative x, because when we combine them we get 0, meaning that they kind of just go away actually. And the next set also will cancel out. So this red x will cancel out this black negative x. And then we've got this red positive x will cancel out this black negative x. So 3 of them canceled out with each other, and we're left with just this 2 positive x's. So I've written that down there. And then we've got this negative 1 combined with this positive 1, and so forth. 1, 2, 3, 4. 1, 2, 3, 4. And what are we left with? We got these 2 negatives, so that becomes a negative 2. We can't combine them because they're different shapes, and this would be the simplified expression. Then finally in this problem it says to evaluate this expression when x is 8. So let's go and rewrite this. I have a 2x minus 2, but we're going to replace the x with the 8 because that's what it said x is. I'll use black. And let's evaluate this using the order of operations. Multiplication first gives us 16 minus the 2, and that will end up being 14. So this would be our second answer for this problem. If you're still working, just keep working, but simplify. 3 times x plus 1 will justify this with words and pictures. So I'm going to do it with pictures because, well, drawing's fun. So let's make an x a rectangle, and then we'll make a positive 1 a red circle here. The thing is it says that it's 3 times x plus 1, which means we would have 3 groups of x plus 1. So there's one group. Let's draw a second group. There's 2. And then we need a third group, right? Bam, there we go. And these are positive 1s. And these are our x's. 3 x's and 3 1s, which if we simplified this, we can see from the x's that we've got 3 x's and then 3 positive 1s. Bam, simplified. Now on the test you guys won't be required to show models like this, but it may help you to understand what is actually happening with the whole distributive stuff. Would someone like to solve when x is -4 for us? All right, thank you.
Okay, well,
Do we get full
we
points?
have 3x and x equals 4. So we know that 3 times 4 plus 3. So this is timesing by that, so that's 12 plus 3 equals 15.
Bam! Nice work. That is it. All right, so this happens every once in a while. I think I said that wrong, so it's my fault, but it's a -4, my bad. Well, that's not going to change much, just going to make that a -12 right there. And we'll just switch this right to old -9er. There we go. All right, by the way, you could have used the original expression as well. And this is a good way to check it, is to use that original expression and make sure that you get -9 as well, because then, well, you've double checked it using 2 different strategies, or at least 2 different expressions. All right, here's an expression, and we just want to simplify this. We don't really need to solve. If you want to use tiles, you can.
Better not miss.
All right, good luck. If you need more
Okay.
space. Do you need more space?
I think I'm good.
All right, either way.
Okay. So first, I'm gonna combine like terms. So negative. Okay, I did that. Then. Okay. I'm going to distribute the 8 in the parentheses. So it'd be 8. Yes. I did something. Wait.
Something's usually good.
You start
There you
pressing
go.
random buttons.
Oh, there, okay. There, and then if I combine like terms, that'd be no. I'm just simplifying it.
Got it?
I don't think I did.
All right, bam. Not necessarily. So, you're saying that we got to distribute the 5 first. What about this problem means that we would have to distribute the 5 first?
PEMDAS.
That's right. The order of operations would do it. This between the 5 and this parentheses is multiplication. And you got to do multiplication before you add those. Okay. Now, it's been a long summer, so I know most of you guys forgot that. So this is a good review of, well, that. So let's distribute the 5 first. Then we'll look to combine like terms, right? So then we'd have this -4x plus 3. And then that would be 5 times 2x would give us 10x's minus 5 times 1, which is 5. Now just be careful, because once again, it's very common for me to see on a test while you show your work a 1 right here. That would be very bad. What that means is that you distributed, and some people even show that distribution rainbow there to the 1, but they forget to distribute. Don't forget to distribute the 5 to that 1 and make this a 5. Now we can combine like terms. Some of you guys remember this from last year, this technique of using shapes to identify like terms. And each term should take the operation to its left, addition or subtraction. So we got -4x, we can do this one over here, plus 10x, which would be 6x. And then we got this +3 and this -5, which if we combine, we should get -2. Bam. There we go. All right, here we go on this one. This one's very dangerous, so you got to be very careful.
Why can't we just do it on the board? I know, but why can't we use the markers? Like the green one.
So the negative just means a -1, and then you distribute So it's 12 minus x plus 2, because the negative and the negative create a positive, plus 4x. And then combine like terms like that. So be 14 plus 3x.
Very good. So I'm just going to point out once again, one of the problems we see on a problem like this is that when we distribute, you'd get 12 minus the x, that's good, but then you get minus 2. Notice she put this plus 2, which is what it should be, right? Because essentially we're distributing this negative 1 into the parentheses, and negative 1 times this negative 2 would be a positive 2. Okay? So don't forget that this would be a bad example right there, right? So this one is the one that we want. All right, take a moment and write 3 expressions that are equivalent to 6x plus 12. You can use tiles if you need, but they're not necessarily required. Do you mind writing yours, please? I just one of them.
Oh.
That's good. Excellent work. That's a 2 right there at the end, right?
Yeah.
It's hard when it runs out of room. All right, do you mind showing us yours, please?
Okay.
Very nice. It's good to see some distribution in there as well.
Did I just do it on the board with the marker?
This is the board
Why?
because of technology.
Okay.
Okay, that works too. Let's get one more. Over here.
I have like more of a question. So I just did different numbers. I can't do that anymore.
Yeah, they're all equivalent.
So I can do that. Okay.
Bam, there we go. Excellent work.